Welcome to the hidden layer. You know that feeling when your AI coding assistant is an absolute genius 1 minute and then the next well, completely useless. You're definitely not alone. And today, we're going to decode the research that might finally fix that. We are diving deep into a really fascinating new paper that suggests a whole new way to train AI coding agents. It's a method that's designed to take them from being frustratingly inconsistent to, well, actually skilled and reliable. I mean, we've all been there, right? You give an AI a coding problem and boom, it nails it. You're thinking, this is the future. Then you give it a slightly different problem, something that seems just as simple, and it just completely falls on its face. It's that whiplash that makes it so hard to really trust these tools in our day-to-day work. But what if we could actually fix that inconsistency? This paper lays out a roadmap for building AI agents that don't just copy-paste solutions they've seen before, but actually learn the fundamental skills of a software engineer. We're talking about creating an AI you can finally, truly trust in your workflow. Okay, so to really get why this new solution is so clever, we first have to talk about the core problem. Why are today's AI coders so brittle? So right now, the way we usually train these AIs is on these big, chunky composite tasks. Things like fix this bug or refactor this entire module. And this visual here just shows the problem perfectly. If you train an AI only on bug fixing, it doesn't really learn how to do something else, like refactoring code. It's kind of like teaching someone to build one very specific Lego castle, but never actually giving them the individual bricks. They can't adapt or build anything new. And this quote from the paper just hits the nail on the head. The models end up with brittle policies. What that really means is they aren't learning how to solve problems. Nope, they're just memorizing patterns that work for very specific tasks. So the second they see a problem that doesn't fit that memorized pattern, they break. And this is where the research flips the whole script. It introduces this brilliant paradigm shift. Instead of training on giant tasks, what if we trained on fundamental skills? Let's go back to that diagram. The new approach, which you see on the right, is all about breaking down those big composite tasks into their core components, what the paper calls atomic skills. This is like giving the AI the individual Lego bricks. Once it understands what each brick is and how it works, it can start combining them in all sorts of new ways to build pretty much anything you ask it to. So the researchers went and identified 5 of these core atomic skills that really underpin almost everything we do as software engineers. First up, code localization. Can the agent even find the right files to change in a big code base? Second, code editing. Can it then make the right changes to that code? Third, issue reproduction. This is a good one. Can it write a script to prove that a bug even exists in the first place? Fourth, unit test generation. Can it write good tests to make sure the fix actually works? And finally, code review. Can it look at a piece of code and check it for quality and correctness? And this right here, this is the key insight. The whole idea is that if an agent can get really, really good at these 5 fundamental skills, it can then combine them on the fly to solve a massive range of complex, high-level tasks. And here's the really wild part that we're going to see in the results. Mastering these basic skills lets the agent solve complex problems that it has never been explicitly trained on before. Okay, so how did they actually teach an agent to do all this? Well, the method they used is just as elegant as the idea itself. Let's break down how they pulled it off. This diagram gives us a great look at the training pipeline. So they start by creating separate datasets for each of those 5 atomic skills. Then they have a single agent that interacts with a safe, sandboxed coding environment. But here's the really clever part. That one agent is trained on all 5 skills at the exact same time, using a method called joint reinforcement learning. So, in simple terms, what is joint reinforcement learning? Well, you can think of it like having one single AI brain, or policy, that gets rewards for getting better at all 5 skills. So instead of training 5 different specialist AIs, you train one generalist AI to be good at everything. This actually forces the agent to find the shared patterns between the skills. For example, maybe the logic needed for a good code review also helps it make better code edits. It creates this amazing positive feedback loop where getting better at one skill helps it get better at all the others. Okay, so the theory sounds great, but does it actually work in practice? Well, this is where things get really, really exciting. The data, folks, speaks for itself. Okay, just a look at this chart for a second. The difference is dramatic. The blue bars show the old way, training an agent only on the big bug-fixing task. And sure, it gets a little better at bug fixing, but look, its performance on other tasks like code refactoring actually gets worse. Now look at the red bars. That's the new method, training on all 5 atomic skills at once. Performance just shoots up across the board, not just in the individual skills, but in those big, high-level tasks too. It's a night and day difference. And this table right here, this really shows the power of generalization. These are tasks the agent was never specifically trained on. And look at those numbers. A more than 15% improvement on a standard bug-fixing benchmark, a nearly 30% jump on multilingual coding tasks. That's huge. And a 17% gain on code refactoring. It's incredible. By learning the basic building blocks, it just got better at, well, everything. So what's the bottom line? Well, when you average the performance out across all 10 of those different tasks, both atomic and composite, the new method delivers an 18.7% performance boost. In the world of AI benchmarks, that is a seriously significant leap forward.
But you know, this is more than just a cool research paper with some nice charts. This has very real, very practical implications for any engineer out there who's trying to build or even just use AI agents today.
So, why should you as an engineer really care about this? Let's break it down. First, it leads to way more predictable behavior. Because the agent is built on these specific, testable skills, its actions are far less of a black box. Second, it's so much easier to debug. If the agent messes up, you can actually test each of its atomic skills one by one to find out exactly where things went wrong. Third, and this is the big one, it just means better reliability because it fails way less often on new problems. And finally, this is really a foundational step towards an AI that doesn't just match patterns, but actually reasons like an engineer by putting skills together to solve a problem. So ultimately, this research is offering us a new paradigm, a new way of thinking. It's a roadmap for moving beyond these brittle, unpredictable agents and toward building robust, general AI partners. It's really part of a bigger trend we're seeing in AI, a shift toward models that are more modular, more understandable, and most importantly, more trustworthy. And all of this leaves us with a really fascinating question for the future, doesn't it? Is this idea of breaking things down into atomic skills? Is this the key that will finally unlock an AI that doesn't just write code, but one that truly understands the craft and principles of software engineering?
So, what do you think? Is this the future for building AI agents we can actually rely on? Let me know your thoughts down in the comments. And hey, if you found this breakdown useful, make sure you subscribe to The Hidden Layer for more deep dives into the AI that's changing our world. Thanks for watching.